Hi class, this is section 6.2, Exponential Functions, Part 1. Okay, so we've already seen the graph of f of x is equal to 2 to the x. So this is an example of exponential growth. We see that the graph goes through the point 0, 1, 1, 2, 2, 4, 3, 8. And then if we plug in negative values, negative 1, 1/2, negative 2, 1/4, negative 3, 1/8. And then if we switch the base from 2 to a number like 1/2, so a fraction between 0 and 1, then we get exponential decay. So this graph goes through the point 0, 1 still, but now 1, 1/2, 2, 1/4, 3, 1/8. And now if we plug in negative values, negative 1, 2, negative 2, 4, and negative 3, 8. Okay, so these are characteristics of our new parent function, b to the x. Okay, so if b is a value greater than 1, we will get exponential growth. And if b is a fraction between 0 and 1, we have exponential decay. So the domain of these functions is all real numbers. Their range is from 0 to infinity. There is no x-intercept. Okay, we have a horizontal asymptote here along the x-axis. Okay, so the line y equals 0 is our horizontal asymptote. The y-intercept is 0, 1. The function is increasing if b is greater than 1 and decreasing if b is between 0 and 1. I mentioned the horizontal asymptote. And then also both of these functions are one-to-one functions, which means there exists an inverse function, which we will talk about later in the chapter. Okay, so an example of 2 to the x. So this we did in an earlier video. So if I plug in 3 to my exponent, I'd have 2 to the negative third power. So remember, if we have negative exponents, we bring them down to the denominator to make them positive. So we end up with 1/8. 2 to the negative second power is going to be 1 over 2 squared. So we get 1/4. 2 to the negative first. 1 over 2 to the first, so 1/2. 2 to the 0, remember, is equal to 1. And then we'd have 2 to the first, which is 2, 2 squared, which is 4, and 2 to the third power, which is 8. Okay, so there are our y values plugged in, and then the graph of 2 to the x one more time. Notice that the graph of 3 to the x power looks very similar. So this graph is going to go through the point 1, 3 as opposed to 1, 2. It goes to the point 2, 9 as opposed to 2, 4. And then when we plug in negative 1, we're at 1/3. The graph of y equals 10 to the x is another example of exponential growth. Okay, so notice the y-intercept for all these graphs is the same, since 10 to the 0, 3 to the 0, and 2 to the 0 equals 1. But when x is equal to 1, here we're way up at 10. So we see that, if the base is bigger, then that exponential growth happens faster. And we talked about the number e before. So remember, e is approximately 2.7 or 2.718. So it's between 2 and 3. So the graph of e to the x still has exponential growth. And when we plug in 1, the y value is this number here between 2 and 3, so approximately 2.7. Okay, so now we want to graph these 4 functions, and we'll graph them using transformations. Okay, so the transformations is just like we've been doing. Okay, so here the parent function is 3 to the x. So we're thinking exponential growth, and then that plus 6 is going to move it up 6 units. So I'm going to start by putting in the new horizontal asymptote. So that's way up here at y equals 6. And then I have my other points, so we can move over here and verify them. Negative 1, 0, and 1 for x values. So 3 to the negative first power is 1/3 plus 6. We can just write that as the mixed number, 6 and 1/3. 3 to the 0 power is 1 plus 6 would get us to 7. And then 3 to the first power is 3 plus 6, so we're up at 9. Okay, and then just sketch the graph. So again, these are just rough sketches, so make sure that you have this exponential growth function. You'll be asked to label 3 points in any asymptotes. So in this case, I just let x equal -1, 0, and 1, and that's because I wasn't changing my x value at all. Okay, so I didn't have to change the input. There was no horizontal change. So -1, 0, and 1 are good x values to pick. Okay, so there it is graphed with Desmos. Moving on to the next one. So this time y equals 2 to the x plus 5. So this time that the change is here with the x. Okay, so in the last problem, the plus 6 was outside. That moved the graph up 6. Here, the x plus 5, that plus 5 is with the x. So this is a horizontal change. Remember, horizontal change is always the opposite. So adding 5 really moves the graph to the left 5 units. Okay, so now when we pick our x values, I want to incorporate the fact that it's been shifted to the left 5. So I want -5 to be one of my x values, and then we'll also do -6 and -4. Okay, so I'm picking -6 because now my exponent is going to be -6 plus 5, which is -1. So I come up with 1/2. If x is -5, I have 2 to the 0 power, which is 1. And if x is -4, 2 to the first, which is 2. Okay, so over here on my graph, horizontal asymptote is the same. So still y equals 0. And then we have -6, 1/2, -5, 1, and -4, 2. These are all pretty far to the left. So if you wanted, you could choose, -3 or -2 as well. Okay, but there's a rough sketch of our graph. Next we have part C, which is y equals e to the x minus 2. Okay, so remember, these are just rough sketches. So the graph of y equals e to the x is an example of exponential growth. The -2 will move the graph down 2 units. So we could draw in our horizontal asymptote. So it's at y equals -2. For the x value, we'll just do -1, 0, and 1. Okay, so we have e to the -1st power minus 2. So you could find a decimal approximation. If you want e to the -1st power is the same thing as 1 divided by e, and then minus 2. E to the 0 power is 1 minus 2, so then we're at -1, and then we have e to the 1st minus 2. Okay, so I'll start with plotting 0, -1. Okay, so the y-intercept, and then I'm just going to sketch the graph from there. So e is approximately 2.7. So if you have 2.7 minus 2, it's actually 2.718. So we'd be at 0.718, right? So that's approximately where that is on my graph. Okay, and then finally, the graph of y equals 3 to the -x. So remember, negatives cause a reflection. Here the negative is with the x, so the graph will be reflected about the y-axis. If I pick some x values, we can still do -1, 0, and 1. But then if x is -1, we would have the opposite of -1. So that would be 3 to the 1st power, which is 3. The opposite of 0 is still 0. So 3 to the 0 is 1. And then if x is 1, we have 3 to the -1st power, which is 1/3. Okay, so we have -1, 3, 0, 1, and 1, 1/3. So notice that now we have exponential decay. Horizontal asymptote is still the line y equals 0. Okay, so we took our graph that was, so the base is 3, so you're thinking exponential growth in your head, but then once it's reflected about the y-axis, it becomes exponential decay. Okay, and there it is graphed on Desmos. Okay, so when I ask you to graph functions, you'll be asked to label 3 points on the graph and also any asymptotes. So that means draw in the asymptote and also label it. So when I first did this, we had y equals 6, y equals 0, etc. So tell me the equation of that horizontal asymptote, and then label 3 points either directly on the graph or off on a t-table.